Alright, it's time to build your virtual answer key for your vectors test because, well, like we know, it's coming up, and we need to make sure we know what we are doing in the world of vectors. So, starting with just graphing them, finding the component vector, then finding the length. The graph should be the easy part. You always start at the initial point, go to the terminal point, and draw an arrow. It's a directed line segment. To find the component vector, we're going to do for the first component, final minus initial for both parts, 3 minus 0, so I get 4, 3 for this one. Then to do the length, I'm going to take the numbers I just found and put them under a square root and square them. It's Pythagorean theorem. 4 squared plus 3 squared, that'll give me the square root of 25, which in this case is just 5. Do the same thing for these, so final minus initial, 5 minus negative 1, 8 minus 3, so that should give me a 6 comma 5. And then square root of 6 squared plus 5 squared, which means the square root of 51 for the second one. For the third one, same thing. 1 minus a negative 2, 8 minus a negative 4, means it's 3 comma 12. We're going to put that one under a square root. 3 squared plus 12 squared will give me the square root of 153. But this can also be reduced. We can pull out a 3 square roots of 17. Okay, the next part, finding linear combinations and combining here. For the first one, u minus v, we're in the component form, so all I'm going to do for here is the first component is going to be the u first component minus v first component. 6 minus 3, same with the second part, 4 minus 2, which means I'm going to have 3 comma 2 for the first one. Okay, y minus x. So for this one, I'm just going to kind of look and see, well, this is in the linear combination mode. So we need to, we just need to go and actually write it out. Negative 10i minus 9j, that's y, minus the entire thing of 4i plus j. So we're going to have to distribute that negative sign when we do this. In the end, negative 10i minus 4i, so we have negative 14i. And then negative 9j minus another j will give me negative 10j. Okay, number 6, very similar. We're going to do 3 times everything in x, so 4i plus j. And then for the second part, plus 2 times negative 10i minus 9j. When I simplify that, I'm going to end up with 12i plus 3j plus a negative 20i and then minus 18j. That's a j. So can I simplify it? Absolutely. I have 12i and negative 20i. That gives me negative 8i. And then 3 minus 18 gives me negative 15j. So that's my final answer there. This one should be very similar. We're going to do 9 times vector v, which is 3 comma 2. And then we're going to subtract that from 4 times vector u, which is 6 comma 4. So I'll simplify that. I can essentially distribute in that 9, so 27 comma 18. 18. And then subtracting here, this is 24 comma 16. And the same thing, I can subtract each individual component, so that means 27 minus 24 is 3, 18 minus 16 is 2. So we have 3 comma 2 yet again. Okay, moving forward to number 8, the unit vector of vector v. Well, we say vector v is 3 comma 2. To find a unit vector, we need to find the length of v first. So the length of v is just going to be 3 squared plus 2 squared all under the square root, which is the square root of 13. So that means my unit vector, all I'm going to do is take vector v, 3 comma 2, and I need to divide each one of those by square root of 13. So 3 over root 13, 2 over root 13. That's my answer, just like that. All right, the length of u minus v. Well, we found u minus v in the first problem in this section right here. U minus v was 3 comma 2. So this is the same as the length of the vector 3, 2. So as we do this, we need to go and do the same exact thing. Well, we kind of just did it in this one. It's the exact same vector, 3 minus 2. So that means that the length of this is, again, square root of 13. All right, next one, the unit vector of x. That means, again, we need to do the length of vector x. To do that, we're just going to do the square root of 4 squared, plus in front of j is a 1, 1 squared, so that's the square root of 17. So the same thing, I'm going to take vector x, 4I, plus j, and I'm going to divide both of them by the length. Divide by 17, or root 17, divide by root 17. That's all you need to do. And then for the last one here, for the length of vector y, square root of negative 10 squared and negative 9 squared. Make sure when you do in your calculator, you're doing those parentheses, and I should get the square root of 181 for that one. And believe it or not, that cannot be simplified. Okay? A couple more. We just did number 11. Let's look at number 12, the component vector of y. So we just need to turn vector y into a component vector, which is just something with the angle brackets. Whatever's in front of I becomes your first component. Whatever's in front of j becomes your second component. And then to find the direction angle of vector x. To do that, I'm going to say that tangent of theta is always y over x. Well, what is y? What is x? Well, the y portion comes from j, and the x component comes from the I part. So I is going to be 1, x is going to be 4. So to get theta by itself, theta is tangent inverse of 1 over 4, which is 14.04 degrees. All right? This should be easy 4 points, sections 3 and 4. If all we're doing is writing first from component to linear combination, then linear combination back into component form. So for this one, 2000 is the first one. We put that with I. And then 4, 5, 6, 7 is the second part. It goes with J. Same here. Negative 45 goes with I. And then negative 67 goes with J. Negative 45I minus 67J. Same here. Now we're going backwards. Part with I goes with the first component. Part with J goes with the second. Same here. Part with I goes with the first component. Part with J goes with the second component. And now for the big finale, the big finale, we need to do vector 1 and vector 2, finding the resultant. All right? So to do this, first we're going to find the x components. So we're going to start with vector 1. To do that, we're going to say that, well, x, we're doing cosine. X is cosine. And then when we do y down here, we'll be doing sine. So don't forget x and y, x is cosine, y is sine. So for B1, I'm going to say that cosine of the angle, cosine of 198 degrees, will equal x over 345. That means that x will equal 345 times cosine of 198. Same for this part down here for vector 2. Cosine of 78 degrees in this case will equal x over the resultant, or I'm sorry, not the resultant, the distance, the magnitude, x over 267. That means x equals 267 cosine of 78 degrees. So when I plug these into my calculator for the vector 1, I should get negative 328.11. And for the second one, I should get 55.51. Now, to find the resultant vector, v of r, all I'm going to do is add these two up. So I'm going to get that x equals the sum of these two, which is negative 272.60 as my answer here. Okay, I do the same vector 1 and vector 2. This time I'm finding the y's, I'm doing sine. The sine of 198 equals y over 345. And sine of 78 is equal to y over 267. Same thing, that means here that y equals 345 sine of 198. When I just rearrange it, and then here y equals 267 sine of 78, which equals, in each case, first one is negative 106.61, and the second one is 261.16. So again, to find the resultant of v sub r, all I'm going to do is add these two up. It means that x equals the sum of those two, which is 154.55. Now, to determine the quadrant, all you need to look at is, whoops, this should be y, is with x and y. In which quadrant is x negative and y positive? Well, if we had our coordinate plane, x being negative means I'm going to the left, y being positive means I'm going up. So I should be somewhere here in quadrant 2. So my answer here is quadrant 2. Sketch what the resultant should look like. All you really need to do is just draw something in that quadrant as your vector. Now what we're going to do beyond this now is to then look and say, well, whatever I do from here on out, there's the triangle. This right here is what my theta is, that little angle there. That's the reference angle you're going to use. And we're going to use that in this piece right here. Redraw, so you can see, here's my resultant. There's the triangle. There's theta on the inside. Find the angle that we want to use. Now the angle is not theta. We need to find this angle right here, going out like that. So to do that, we're going to use the tangent function. Tangent of theta, which is y over x. Well, what is y, what is x? Well, that's what we found earlier in parts 13 and 14. Y from 14 was 154.55, and x was negative 272.6. Now, when we do this, we just want to find this angle in general. We don't need to try to be precise, and the calculator is going to try to lie to you. So make everything positive when you do this. So that means that theta, to get theta by itself, I need to take the inverse tangent of that fraction, 154.55 over 272.6. And that means that theta is going to equal, when I plug that into a calculator, 29.55 degrees. Now again, that's what theta is. We need to find this reference, or that is the reference angle. We need to find the entire angle. So my entire angle that I'm going to have, because I'm in quadrant 2, to find it from the reference angle, I need to do 180 minus 29.55, which means the angle that I actually want is 150.45 degrees. Now, the last part, to find the magnitude of the resultant vector. We have two different options we can do. The first one is we can say that sine of theta, we said is y over r. Well, I know what theta is, I just found it. So sine of 150.45 degrees is equal to y over r. Y is 154.55. R, I don't know. So that means that r, since it's on the bottom, it's going to switch with the trig function, the sine. So r will equal 154.55 over sine of 150.45 degrees. When I do that, I'll plug it in, and I should get 313.37 for my answer. And the other option that you could do, if you don't want to do it with sine, you can always say that the magnitude is the length. So I could do it with a square root of x squared plus y squared, which is the same as, in this case, same thing. X was 272.6, square that, and then 154.55 was my y. I square that. Taking on the square root, guess what? I get the exact same answer, 313.37. So, to do the final step, finding the resultant vector, it's just putting it all together. I'm going to kind of scoot it down here where I have more room. The final answer for this is simply to say that v sub r is equal to the magnitude, 313.37. That was in newtons. We want to make it look just like we did up here. 313.37 newtons at my angle being 150.45 degrees. Should look very similar to what that is up there. All right, hopefully this has got you ready to go. Hopefully you're in good shape for the vectors. This last part is going to be worth 10 out of the probably 40, 45 points. So make sure you can go through one of these problems one step at a time. If you make a mistake early, it's no big deal as long as you continue the rest of the way through with no issues. Hopefully you're in good shape. Have a good evening.